Hello everyone, welcome to another video. In this video, we're going to talk about when to use which collection data type throughout your program. Starting off by talking about strings, really, they are used often within collection data types, but if you are doing anything that is text related, you're obviously going to be working with string objects and using their various methods that they contain and so on. So I'm going to be skipping that portion. Now we're going to talk about sets. Now, one thing I want to note is that when you use a set, you should really keep the data type of each value in the set consistent. So you shouldn't really try to have a mix of strings, integer, or tuples all inside a set, but it should be either all strings, all integers, or all tuples. And that's going to lead to my next point. When you want to use a set, your data type should all be either string, integers, or tuples because we must only have immutable data, which and later on, you're going to learn that is actually because sets are a hash table in Python. When we're using if statements and where where a variable could be equal to multiple but unique values, that's a good time to use sets. When we're forbidden to have duplicate values, or if you even want to remove duplicates from a list, you can convert it to a set, and that should get rid of all duplicates because it'll make our set just have single versions of all the unique values that are found in a list. So let's look at an example scenario here. In line 14, I have this variable called fruits and vegetables, which is apple, banana, carrot, spinach, orange, broccoli, grape, and tomatoes. It's like a mixture of fruits and vegetables. And what we're going to do is initialize these two variables. Fruits is equal to 0, vegetables equals 0. There is set to 0 because we haven't found any, and we're initializing them. And we're going to increase them by 1, as every time we encounter a fruit will increase, and every time we encounter a vegetable counter will increase, and we'll use those as counting variables, and they've been set to 0. We're just going to write a simple for loop here. We're going to say for item in fruit and vegetables. Since we don't know what it is, we just called it item, and we're going to be looking through this list one by one, which has strings of different fruits and vegetable names. If you notice here in my line 20, I am using the in operator, which is a membership operator, to check if item is inside this set. Whereas in elif here, I'm saying if item is in either carrot, spinach, or broccoli within a list. So the main differences here is that we have a list. In this situation here, we have a set. So the cool thing about a set is the following. And we're going to talk about the cool part by looking at the vegetables first. When we do the in operation on a list, we end up doing a linear search. It will go from the left and it will go towards all the way to the end of the list until we either found the item or not. Whereas a set, it doesn't do that. It actually translates whatever this value is and see if that is existent as a possible address in our set. Because each of the values that we have inside our set, the values themselves are also the addresses of themselves. So therefore, if I wanted to go to the location of banana, I don't have to look through one by one, but rather just go to the address of where banana is located. And if that is existent, that means we are guaranteed to have banana. So in terms of finding a value within a set is much quicker rather than looking through linear search because it's just a single check that we have to do. We go to the location of where that value could be located because the location themselves are the addresses themselves. Whereas in line 23, lists deal with their addresses based on integer values. So there is no way to know where this item could be located anywhere within this list. Therefore, we must start at the left and go all the way to the right. And this portion of our code will run much slower than this portion. So in a situation like this, if I were to run our code, what it does is it outputs how many fruits we had and how many vegetables we had based on this logic system. So when you encounter situations like this, when you're using a membership operation, it is highly recommended that you use a set. So we'll now turn this off, and now we're going to look at dictionaries. Dictionaries are powerful. Like if you have a need for a dictionary, I would definitely use it. But mainly when each data item needs a unique non-integer index value. So for example, if you wanted to store that address of name is assigned to a value Jasper, like that's a really relational database that you can have, and that's all possible with dictionaries. When you're worried about frequency of data, which we're going to talk about next, it's really nice to have a dictionary. And if you want to work with multiple data at once, that is similar to a JSON file, which is a JavaScript object notation file, which is really, it's like it will look like a dictionary of dictionaries and so on. And that's really nice when you want to have that kind of feature. So in this set of code here, okay, well, I have a long paragraph. The paragraph reads, in the garden, the apple tree stood tall. The apple tree was full of ripe apples. Children loved to pick apples from the apple tree. The garden also had a vegetable patch. The vegetable patch had carrots, spinach, tomatoes. The tomatoes were juicy and the tomatoes were red. Every day, the gardener watered the vegetable patch and the apple tree. And the garden was a place of joy with apples and vegetables and growing abundantly. Right. And if you'll notice here, I wrote a little frequency counting function. So before we get there, I'm going to do some special stuff to this paragraph. As you see here, what we want to do is count the frequency of the words that existed within this paragraph. But for us to do that, we need to make sure that our data is comparable. So we're going to make everything into a lowercase. We're doing multiple string methods applied onto a string, which is our paragraph. So we're going to say, hey, paragraph, you're going to get, first of all lowercase. Then we're going to replace every single comma with an empty string. And then we're going to replace every period with a empty string, so on. So if I were to then show you what that would look like, instead of this beautifully structured paragraph, we have this unstructured paragraph with only spaces in between them. Then what we're going to do is the following. I'm going to comment these, and I'm asking, hey, I'm going to create a new variable called word_list, and I'm going to split the paragraph based on finding spaces. So every time I see a space, then I know that the word before that is a word, and the word after the space is a word. So if I were to now run this code, I'm able to put all the individual words that we found in our paragraph into a list. And then if we have a list of all the words that existed in the paragraph without worrying about order, we can now run our frequency function. So I've defined a quick frequency function, and what it does is takes a list, and we call that list that we get data, and it's going to return a dictionary. And we're going to say that, well, inside this frequency function, we have a empty dictionary, and this is an empty dictionary, not an empty set. We're going to say that result is equal to this empty dictionary. And then we're going to say that for all the items that we see in our data, if that item is a key, as in we've seen this item before, well, that just means that we can increase the counter or increase the integer value at that location by 1. Otherwise, in that dictionary, if we have never seen this item value, then we're going to generate that value as a key, and then we're going to set the counter as 1 because it existed at that location. And afterwards, we're going to return our result. So now if I were to execute my code, we can say that the paragraph word frequency is, well, the article the occurred 12 times. There was apple occurring 4 times, tree occurring 4 times, and so on. And this is a really nice data set to have when you're looking at maybe like cheaters who often cheat on essays or something, where if you know like the frequency and the usages and the characteristics of their sentence creation and paragraph creation, you can see that if someone copied from one another. So it's a really interesting function that you can create. So now let's turn that off. And the last two things we're going to talk about are tuples and list. So basically, we use a list when you are not using a set or a dictionary. So let's say you are in an ambiguous situation where you can potentially have duplicates, so sets are out of the question. You might also have really different set of data types going into a data set, then you can't use a set. And you don't really care about special indexing per item, and you don't care about the uniquenesses of each index of an item, then really you might not need a list. You might not need a dictionary. You can definitely use a list. But when will we use tuples? Why would I want an immutable version of a list? Well, that's when you want a function to return multiple values in an immutable container. And sometimes, since dictionaries requires immutable data types as its key, we can assign tuples as dictionary keys, which is super powerful when you have a very unique key per data item. But in this situation here, I've created a simple function which takes a numerator and a denominator, and the function purpose is to divide. And it's going to do a floor division and also track the remainder of that division as well. So we're going to say that our A is the result of num floor divided by the denominator, and we're going to say that B is a result of num modulus denominator, and we're going to return both values at once. So if I run this code, we're going to know that 5 divided by 2 is equivalent to 2 with a remainder of 1. So it returns a tuple with the quotient being the first value and the remainder being the second value. So this is really nice when you write functions that should return multiple values. You can store them in a really nice container of an immutable tuple where the values within that collection won't get modified. So I hope you enjoyed that video. I hope it cleared up some of the questions that you may have about when to use these data types. But as you program more, and you always want to code the easiest way first, and you can always look back and say, like, well, how could I improve this? How could I use a different data set to do so? And those are all good thinkings to have. And as always, thank you for watching and stay classy.